And 2 months ago at Singapore, we asked the question, are we in the midst of a rollup boom? And the answer was a resounding yes, right? I think everybody's excited. And today, the question we're going to ask is, what does it take for the mass adoption of rollups? I was having a brief chat with Ed Felten, who's coming up shortly as our keynote speaker to address this particular topic. And I asked Ed, how many rollups do you think we will have in 2025? And he said a few hundreds. Well, it could be 200, it could be 999. Well, let's hope it's 999 plus. So let's welcome Ed Felten. Ed is the chief scientist and co-founder at Offchain Labs, who are building Arbitrum. So Ed has been with the company since its inception from September 2018. And he's been the chief architect focusing on the scalability of Arbitrum. So Ed, the stage is all yours. Take it away.
Can you hear me now? Great. Okay. All right. I want to talk about the future of L2. In particular, I want to talk about the mission that so many of us share, which is the mission of onboarding the next billion users. Now, that is easy to say, but it's not so easy to do. And I want to talk in particular about how we get there. I'm going to talk generally about what attitude we need to have as a community, and also about some of the particular moves we should make. So the first thing is, in terms of attitude, there's a lot of talk about alignment, and what does alignment mean, and how we need to be aligned. For me, what matters is user alignment. We need to align with our users, and we need to make technologies that are compelling to them. And if we all align with our users, then we will be aligned with each other, and aligned in the right direction. Now, I want to talk about 6 big moves that we, as a broad community, I think can and should be making. Some of them are already underway. Some of them will happen going forward. And I'll talk specifically about things that Arbitrum and the Arbitrum community are doing to help our users get there. The first big move is to build in layers. Now, why layers? Well, layering is one of the great tricks of the internet, which is the most successful protocol ever developed by humanity. And so we can learn a lot, actually, from the development of the internet. Layering has a bunch of advantages. Each layer in the technology can focus on doing one thing and doing it well. And then the layers above can rely on that already being taken care of. The other nice thing about layers, as you can see over here on the left, is the layers of the internet, as they stack up, it's not just a stack, it's a kind of branching tree. The layers allow you to have diversity. For example, with rollups, not every rollup has to be the same. Different rollups can be aimed at different business purposes, different technical configurations. And that diversity that you can have in solutions and approaches is really a valuable outcome of layering. So building our technology in layers is really important. And that's why we started out long ago with the idea of layer 2, which of course has expanded beyond that. Now, Vitalik has early on recognized the value of layering. And in 2020, he published this now famous post about the rollup-centric roadmap, saying that Ethereum was going to bet on a layered approach. And how's it going? Well, the rollup world is very robust. If you look at the capacity and traffic of rollups today on the Ethereum stack compared to the throughput of Ethereum, we see that rollups have about, or layer 2 and 3 have about 30 times the transactions per second that Ethereum can handle, about 80 times the gas, about 40 times the amount of input call data, and there's order of 100 L2 and L3 chains already launched in the Ethereum stack. So this has expanded the scope of what the Ethereum stack can do to a really remarkable extent. Just to illustrate this, let me show you this graph that shows how much gas, how much activity there is in different layers of the Ethereum stack. L1, this is to scale. L1 is about 1.5%, and L2 and L3 split the rest of it. So before layer 2 and layer 3, Ethereum was limited to what on this graph is just that small yellow bar on the bottom. And what you can see is that if we're going to get to the scale we need to grow these L2 and L3 bars even larger. Okay. Now, there's a lot of advantages to, that you get from being at layer 2, from being at layer 3. Essentially, you get more technical flexibility, you get lower cost. But I want to move on and talk about the second big move, and that is to connect everything. If you're building in layers, and if there are many hundreds or thousands of rollups, if there are many hundreds of large ones or many thousands of medium-sized ones, you need to connect them together so that you can provide a really great user experience, even as users are using multiple chains at the same time. So that means that brings us to this topic sometimes called L2 interop, or really L2 or L3 interop. How can we give users a nice experience even as they do things that span across a range of chains? Now, we want to connect everything, but one of the lessons we've learned already is it matters a lot how you connect. Connecting in the right way is key to having a system that's robust and serves the needs of users. So, and again, I think we can learn a lot from how the internet does this. The internet has developed its own way of allowing users to operate across a range of different machines and systems. We do this every day. Everything we do online pretty much relies on internet interop. And it works really nicely. So there are a bunch of focuses that internet interop had that allowed that to happen. There's a focus on speed. There was a focus on it being standards-based so that everything could talk to everything. But then there are particular technical moves that the internet has made. First, that interop is asynchronous, meaning that the parts don't stop and wait for each other. That's really important because stop and wait is a solution to making things slow. Stop and wait is, if you've experienced Bangkok traffic, you understand why stop and wait, it might not be the best approach to getting to your destination quickly. Fault tolerant, so asynchronous means you don't stop and wait for the other component. Fault tolerant means that you have to be prepared for the other component you're interoperating with to not be available, to not be working correctly, and you need to smoothly deal with that. And security conscious simply means that you don't just assume that the other component will be secure. You need to be robust even if the other component's not secure. These moves have allowed the internet to connect things together in a really smooth way. And to give you just an idea of how pervasive these moves are, even in the same data center, if you have two servers in the same data center, 2 centimeters apart, managed by the same people, running the same software, they still operate this way. They don't stop and wait for each other, they don't assume the other will be available, and they don't necessarily assume the other will be secure. That's the attitude we need to take. And I think we can build internet-style interop and provide an internet-style experience for users, even across blockchains, across L2 and L3, and across different blockchain technology stacks. Now, there's basically 2 sort of styles of thinking about how to connect these machines. There's the chain cluster view, where the machines are sort of tightly coupled, and where you force a kind of uniformity onto all of the systems that are being connected. But I think it's much more useful to follow the internet approach and have things be sort of loosely coupled, where everyone gets to use their own approach, their own configuration, everyone gets to manage their own system however it is that they like. And we still get them to work together and make a smooth experience. This, I think, is the key. Uniformity, a type of interoperation that relies on everyone being the same, everyone marching in lockstep, I think is not the right approach. We give up the value of diversity and choice that the current L2, L3 ecosystem provides so well. Big move number 3 is to focus on making sure that we serve developers. This is the mandatory Steve Ballmer image here. What developers really want from the technologies is they want to be able to use familiar and battle-tested programming languages and tools, all of the things that they've come to know and love, and that have matured through so much use in Web 2. Second, they want fast execution. They want the chains to actually run as fast as possible, and they want things to be fully composable, meaning that you don't give up the really nice ability to build transactions that do multiple things, the sort of financial or technical Lego approach that you get with blockchain programming. You don't want to give that up. So the approach we've taken with Arbitrum is something called Stylus. And Stylus takes the attitude that different programmers want to program in different ways. Some programmers want to use Solidity and run programs in the EVM, which is the Ethereum style. Some programmers want to program in other programming languages, Rust or C++ or other programming tools. And why not just do both, right? There are even events here in Bangkok about alt VMs. Should we use EVM or should we use Rust? Well, what our approach is, why not support both? Support both on the same chains, make everything work with everything, fully composable, and so on. This shipped on Arbitrum a couple months ago. So this is not just a vision, this is actually live. And there's a lot of excitement around it because it opens up a lot of new performance and it allows many more programmers on board. As my colleague Stephen Goldfeder likes to say, if you want to bring the next billion users on board, you first need to bring the next million developers. And this is, I think, is a big step toward that goal. Okay, big move number 4 is to make it fast, obviously, but to make it fast for real. You see a lot of claims published in this space, so we can do 1 billion TPS or a billion gas per second or whatever it is. And it's easy to make up an artificial measurement and make your number really big when you're talking about performance. But what really matters, of course, to users is what do you get in real use? What do you get on a chain that has some history, that has a lot of usage, that has a big state, and that is running the things that users actually want to do, and not just some program that you picked because it would make a big number. And so that focus, really relentlessly focusing on practical performance, measured performance, is really key. And there's a bunch of things we can do to get to that point. I'm not going to go through all of these in the interest of time. But basically, it amounts to several things. First of all, having realism about how we measure and how we talk about performance, and having standards for how we measure it. And then just working relentlessly to improve the technology, to make things go faster without changing, without burdening users or without burdening developers with extra work. That should be the job of the system designers to make this system just faster without inconveniencing anyone else. Big move number 5 is technical decentralization. Now, when we started out with Arbitrum back in the mainnet launch in 2021, the system had, I thought, a decent degree of decentralization, and we had a decentralization roadmap. Here's how we're going to get from where we are to a system that's really fully decentralized. We're now getting pretty close in Arbitrum to the end of that roadmap and to being able to say everything is decentralized. And I think Arbitrum has been a leader in that space. But let me talk about what that means. And whoa, we have a formatting problem. Okay, so one of the big changes, which is an upgrade coming soon to Arbitrum, assuming that the DAO votes to adopt it, is called Bold. And although you can't read it, the big move with Bold here is that it makes the step of validating the Arbitrum chain open to everyone. It makes it safe to open that up to everyone. And what that does is it creates this incredible guarantee that any one user with a laptop sitting anywhere in the world can force the chain to execute correctly. Even if everyone else is against you, if you are one person with the truth on your side, it's like in the movies, right? One person with the truth on their side can actually win out. And that's an incredible security property which will be available when Bold is deployed. And so that decentralizes the role of validating the chain. Anyone can do it, and anyone has just as much power as the big players in the protocol. The next big upgrade that's coming is Time Boost, which is about allowing chains to capture some of the MEV revenue. That is some of the revenue that's being extracted by high-frequency traders on their chain. This is a way to return some of that value to chain governance. If it's an app chain, if it's your app chain, that's revenue that you could be collecting and using for the good of your business or the good of your protocol. Now, I'm not going to go into exactly how that works, but the keys about it are that it captures MEV revenue, and that there's a decentralized version of the Arbitrum sequencer that we Offchain Labs are developing jointly with Espresso Systems in the pipeline. We're really excited about that because that will be the last step of the technical decentralization roadmap for Arbitrum. So once that's delivered, we'll be there at that destination that we set for ourselves for technical decentralization about 3 years ago. Big move number 6, the last one, is to decentralize control. And this is really important, the question of who's actually in control of these chains. Now, in an app chain, if it's your chain, you get to decide what is happening. But on the big Arbitrum chains, Arbitrum 1 and Arbitrum Nova, it's the Arbitrum DAO that governs. Or if you have an app chain, perhaps you have a DAO and you want your DAO to govern. And we've worked really hard to build support for that. So what does decentralizing control mean? What it really means is that it is the users who are really in control. If you give users control, they have control. There's not some backdoor. When the users vote to do something, that thing will happen directly on chain. And users have practical control. There's not a group of insiders who actually make the decisions after pretending to listen to the users. So with these 6 big moves, which are well underway in the Arbitrum ecosystem and a bunch of others, we can establish the conditions to get to that mass adoption, to that next billion users. The future of L2, I think, is the future of Ethereum and vice versa. I believe really strongly that we are in this together and that one layer succeeds when the other layers succeed. That's like the internet, and it's the way that layered systems have always worked. And then finally, the principle that underlies so much of this, and especially the app chain idea, is this: your chain, your rules. That is, you have the ability to launch a chain. It can be your chain. It will work the way you want it to work. You have the power to customize it and control it. And that's the goal that we've been aiming at. That's the goal that Orbit and the sorts of services that our friends at Zeeve provide can make available to you. So with that, I'll thank you, and I hope you enjoy the rest of the afternoon.